Hey folks, how's it going? It's really nice to be here. Thank you to Shlomi and the SwampUp team for inviting us. I'm going to talk about building bridges between DevOps, MLOps, and how that is changing in the world of generative AI. It's really quite an exciting time to be alive in the world of AI and to figure out how to apply that to your business and to get all the best benefits you can from it. So just to introduce myself quickly, I'm the CEO of Helix.ml. We have a private GenAI stack. You should check it out. I also am one of the founders of MLOps Consulting, which is a business that works with companies all over the world, consulting on MLOps, as the name suggests. We've worked with clients, all over the world. And we really saw that change and the transformation that happened around 2 years ago when ChatGPT came out, and everyone started figuring out how to try and apply that to their business. I'm also a founder of the MLOps community. This is a great online space to learn about MLOps in general. We have about 20,000 people on the Slack channel. And before that, my career was basically focused on DevOps and then MLOps. So in my first company, Cluster HQ, we were the first people to provide storage for Docker to make stateful containers a reality. I was the SIG cluster lifecycle lead for Kubernetes. So if anyone's ever installed a Kubernetes cluster with kubeadm, I built that, or I was involved in writing that. Then we also did an end-to-end MLOps platform, kind of pre-GenAI that was called .science. So my whole career, I've been kind of working on first DevOps and then MLOps, and it's interesting to see how things are changing. So I wanted to kind of take a step back to begin with and say, well, where are we? What's the current state of MLOps, and what is it? Well, MLOps is the intersection of three disciplines. It's the intersection of software, DevOps, and AI/ML. And so just very briefly, how we got good at software was by version controlling the software that we were writing and testing it. How we got good at DevOps was with immutable infrastructure and making it possible to do continuous delivery so that we could speed up releases. And how we got good at AI/ML was by taking this these mathematical models and being able to expose them to huge amounts of data and have them automatically find the patterns in the data. And when you combine these three disciplines, you get MLOps. So it's quite a lot to take in, but this is kind of how these things intersect. Now, remember, we got good at software and DevOps thanks to version control and CI/CD. Put a pin in that because we're going to come back to that, and we're going to talk about how you can do that as well for GenAI from a DevOps perspective. So now let's talk about kind of how the family tree of MLOps has evolved. So the first thing to break it down into is this idea of serving versus and inference versus training. So training is where you take a bunch of data that you have and you train a mathematical model to predict new things based on that data. And serving and inference is when you then take those model weights and you run them in production and you make predictions based on them. And one thing that happened like a year and a half ago was this ChatGPT moment. What happened was that the deep learning research community finally trained a language model on enough data with enough compute that the machines mastered language. And it's that's pretty cool, actually, when you think about it. We've got to the point where you can interact with something using natural language, and it can reason, and it can communicate with you. So let's break that down a little bit more, because this is all really new. In the last year and a half, we have taken this LLM inference API, which suddenly became super important. As soon as ChatGPT happened, there was this notion of an inference API. And what we've done is we've developed these new disciplines, these sort of sub-disciplines of MLOps in this family tree around prompt engineering, which is where You can iterate on the way that you prompt the models in order to make the model do what you want and to get it to do specific things for specific tasks. There's retrieval augmented generation, which people call RAG, which is just a really fancy way of saying that you take a vector database and you fill it full of your documents, and then you can search over those documents when you do an inference and include relevant documents along with the query to the LLM. I'll talk about that in more detail in a minute. And then we have this notion of API calling, which is where you want to integrate a language model with an external business system. And this is super powerful. Like, if you're able to say, I've got an HR system, and now I can expose a chat interface to it, you can make your business a lot more efficient. And you can do that across all of your APIs, internal and external, and enable all sorts of amazing use cases that weren't possible before. Because remember, like, talking to your computer used to be science fiction. So we can now define LLMOps as all of the things you do behind the LLM inference API, the thing on the right-hand side of the diagram. And there's this interesting boundary, which is that inference API, and the things on the left-hand side of it, I guess on this side, are sort of classical MLOps, and the things on the right-hand side are this new industry, or this new discipline of LLMOps. So I want to point out a few things about this, which is that the things on the diagram in green, you're definitely going to do these things. These are definitely in your future. Every organization, if you're not already, is going to be doing prompt engineering, is going to be doing retrieval, and is going to be doing API calling so you can integrate these models with your business systems. And companies that don't do this are going to have their lunch eaten by their competitors. So it's essential that everyone figures out how to do this thing, even though it's brand new. Things that I've marked in orange, or yellow on this diagram, are things that you might do. You might serve your own models on your own infrastructure. In fact, I think you should, and I'll talk about why that is. But you may also consume APIs from external providers like OpenAI or Anthropic, and so on. Now, one thing that you're almost certainly not going to do, which might not be obvious, is you're not going to train your own large language model. Unless it's very, very unlikely that your organization will need to train your own large language model. And the reason for this is that these large language models, they cost hundreds of millions of dollars to create, and there are very good ones out there already. So why reinvent the wheel? But there is an important distinction here, which is that this is true for these foundation models. But it's not necessarily true for kind of classical non-generative ML models. So for example, I would still expect an insurance company to train their own pricing models and so on. That will definitely still happen. But I'm talking specifically about LLMs here and these kind of GenAI models. And there's one additional important factor here, which is that what you might also do is you might fine-tune your own model, which means taking an existing model that someone's already trained and training it more either on your own specific company data or kind of structure and style. So then we have this kind of notion of a chasm. And there was a chasm in Yoav's talk yesterday. So maybe the theme of this conference is chasms. But there's this chasm now between MLOps, which is about training and serving your own models, and LLMOps, where LLMOps, remember, is everything behind the LLM inference API, behind that piece there. So an LLMOps is all about these application patterns that you can build, and I'm going to show you some of these. But the application patterns are the way that you consume, the way that you use the LLM. And we're all about building bridges, so I'm going to show you how you can build a bridge between this MLOps world and this LLMOps world. And this image, by the way, was generated by FluxDev, a new model that came out of Black Forest Labs. And it's interesting to see that they're kind of production ready now, the image models. They look pretty good. So I want to talk now about consumption models. So this is kind of a spectrum, right? On the left-hand side of the spectrum, you have hosted services like ChatGPT and Claude, like I've already mentioned. They're easy to get started with, but there's a risk if you use these things that these companies will literally train on your data. And if the system is down, I mean, we heard about how, in the last talk, about how important it is to have many backups and failovers. If it's down, then it's down, because it's just an external API. You can also get enterprise versions of these things like ChatGPT, and they promise that they won't train on your data, but then you're still relying on an external system that could go down, and you've still got data leaving your firewall, which might actually be, even if you could do it, might be really hard to do that. So then, on the right-hand side of the diagram, we've got these more safe but harder to implement options, which is things like running your own Azure OpenAI or Bedrock in your own VPC, where you have more control over the data, but that's more complicated to set up, and you lose things like having a nice web interface. You also can get locked in if you do that. And then all the way on the right-hand side here, you've got this thing that I'm really excited about personally, which is fully self-hosted open source models. So there's this really exciting world of open source models that are getting better really quickly, where you get to have complete control over the data and the models and the weights. But this does come with some downsides. There's a lot of models to choose from. They're changing quickly. They can lag behind closed ones, and you need to run models on your own GPUs. But it is possible to do this, and I would encourage people, once they've experimented with these use cases, to try this out. So I want to talk briefly about my manifesto for DevOps for MLOps, and also this new field of LLMOps. And I really believe passionately in all of these things that you need to achieve, right? You need to achieve reproducibility. And it's super important when you're training or fine-tuning a model that you keep track of what version of the data you put into the model. You need provenance so that you know from, just like you do in CI/CD, you need provenance so you know that you can go from an inference that was made in production to exactly what version of the model that was trained on and what data was used and so on. You need to version your prompts. You need to version your model, your RAG sources, and so on. You need a collaborative system, right? Because you work in a team. And if someone goes on vacation, you need to be able to carry on working. So you need to not have systems where everyone in the team does something slightly differently. So that's important to record what happened. And I'm a huge advocate of trying to define a YAML format for these LLM applications so that you can treat that like you do a Kubernetes manifest. And I'll show you the proposal that we have for that in a minute. You need to test these things. So testing these things is different to how you test regular software. When you're talking about maybe a classical ML model, you might look at things like KL divergence, which is looking at how the distribution of predictions in a classifier changes over time. But then with LLMs, you've got a whole new challenge of how do you test and QA LLM applications, especially when they can be quite unpredictable. Now, you wouldn't ship software without tests, right? And you shouldn't ship your LLM applications without what's called evals. And eval stands for evaluations. And evaluations is how you can have another LLM judge the output of your system when you test it under various different circumstances. And so check out evals frameworks, because this is super important. And the idea here is if you have versioning, you have version control, you've defined a spec for your versioning all your prompts, and you have testing, then you can actually achieve this nirvana of software and DevOps best practices, which is to be able to, for example, you have a main branch, and you have a pull request for your LLM app that's changing some of the prompting, maybe the way that you're interacting with an API, and you can actually automatically run the test suite of the evals against that, and then you can know, is this change making the system better or not? Or is it regressing something else? And so you need to build this infrastructure with evals plus versioning for these LLM applications as well. Now, I'm going to go quite quickly because we don't have long, but it's super important to make these things portable as well. And I really think in the world of MLOps, you have to use open formats for data pipelines. I'm quite a fan of DVC, for example, for that, and DBT, two different open source tools. But then in the world of LLMOps, like LLMs, they bring this other challenge, which is that your prompts are not portable between providers. So if you talk to if you use the OpenAI API to develop an application, and then you try and run the same application on Claude from Anthropic or Llama 3, you're going to get different results. And if you've got the evals framework set up, you'll be able to test it, and you'll discover that it's much worse when you move to a different provider. So even though they all use natural language, they interpret the language in slightly different ways. So the solution to this is to use open source LLMs. So look at the work that Meta is doing with the Llama 3, 3.1 series of models. These models are catching up with the closed source ones, and so I strongly encourage everyone to try them. Now, from a security perspective, it's super important to avoid IP and data leakage, and so that's why, as we looked at these consumption models, if you've got anything like classified data in your organization, this slide isn't classified, by the way, it just indicates that, that you should put your classified data on the right-hand side, then you should put these things in locally hosted models that you control kind of behind your firewall. So select an appropriate consumption model. So that was a lot of talking. I want to TLDR that for you. So if you take one thing away from this presentation, the TLDR is version all the things, test all the things, and self-host all the things. And versioning and testing and self-hosting of LLM applications has a different meaning and is implemented in a different way compared to how you do it for software. And so we need to learn these new disciplines. So you can get started with LLMOps today. There are a lot of open source tools. And I'm going to show you a quick demo that I put together yesterday of how you can plug some of these open source pieces together. So what we're going to do is we're going to build a quick RAG pipeline on top of an open model using pgvector and llama index. These are all popular open source things that you find on the internet. And what we're going to do, I'm going to skip over this because because I'm running out of time, but the basic idea is you put content into your vector database, and then you're able to query the model, and the RAG system will grab the appropriate content from the database and include it in the request to the LLM, so it could summarize results using accurate facts that come from the RAG database. So what we're going to do, please pray to the demo gods for me. We are going to get a GPU node, and we're going to install a llama on it. So, and by the way, you can follow along with this simple LLMOps stack that I set up. So we're going to clone this repo. I wrote this with the help of Claude in about 3 hours yesterday morning. And what we're going to do is we're going to install Ollama. Now, Ollama is a piece of software that allows you to run these large language models on your own machines. It works on Mac, on Windows, on Linux. And if you're running it on the server, then you can run it, for example, on a server with an NVIDIA GPU. And it will go ahead and give you nice, fast inference with an OpenAI-compatible API. So now we can go ahead and pull Llama 3.1, and we can talk to it. So let's talk to Llama 3.1. We can say, what is the AI spec? And we'll see if it knows. And what I'm going to do is I'm going to show you something called the AI spec. And I'd like the LLM to be able to answer questions about it. But we have a problem. Like, the LLM doesn't know anything about the AI spec. So let's solve that problem by building a RAG system. So we're going to put together a really simple RAG system. We're going to use Postgres. Who here likes Postgres? Some Postgres fans in the house. So pgvector is a Postgres extension. And I think that, yeah, if you trust Postgres, then just use pgvector. That's just my opinion. Other vector stores are available. Sorry, I didn't clean up after my last run through. OK, so we've got the vector store up and running. And then we're just going to set up a virtual environment. So this shouldn't take too long. So we're just going to install the dependencies. And so while we're doing that, I'll explain what's going to happen. So we're going to use these two scripts. One of them is going to put data into the vector database. And so what you can see here is it's just connecting to pgvector. It's setting up this thing called an embedding model, which allows the words that get put into the system to be turned into a vector, which is just a string of numbers. And the documents in the database have also been turned into vectors, and that allows you to do, it allows the vector database to do a similarity search by just finding the distance between the vectors. That's just a really fancy way of saying, like, it's semantic search. So you've got documents, and you find things that are similar to the question, and then you include those along with it. So let's carry on. So yeah, this should now be working, hopefully. So just 1 second. So I need to do this bit. So I also built a quick little web interface that allows you to see what's inside the vector database. OK. Hopefully this works. I'm using a hotspot on my phone because the conference Wi-Fi wasn't working earlier. So, OK. So far we have nothing in the vector database. So let's fix that. Let's put something in there. So what I'm going to do is, I've got this document, which is about the AI spec. And what I want to do is I want to put this into the vector database. So, because it's quite a long document, I want to be able to answer questions about it. So what I'm going to do is I'm going to do Python, what's it called, ingest data with the URL. And that's going to go and download the contents of that HTML file. And it's going to chunk it up into a few pieces, 4 pieces in this case, in Markdown format. Because these LLMs are Markdown machines. They've been trained on Markdown. They love Markdown. So it turns the HTML into these chunks of Markdown. And then when you query, it will select the most relevant chunks of Markdown. And so you can make these huge databases with like gigabytes and gigabytes of your documents in. And then we can query the data. So let's see. What is the AI spec? And it's going to go and query the vector database. And it worked. So it's pretty cool. OK, so I'm nearly done. I want to leave time for questions. So what I want to show you just before we finish the demo and go back to the slides is this idea of this AI spec. So what we want to do here is we want to say the application patterns that people are building, like RAG, like interacting with APIs, like setting system prompts, like selecting different models, they should all live in a version-controlled manifest, just like the version-controlled manifests that you get when you do like ingress in Kubernetes and things like that, because that allows you to do good DevOps with these things. And so additionally, it should be possible for business people in the business to use a UI to set up these things, to set up an AI spec and to add knowledge to these systems. So you might create a chatbot for Starbucks, for example, for their IT department. And you put in into the vector database this knowledge about what time the Starbucks is open. And then it will respond and cite the thing. And you might also want to integrate with an API. And so if this is the IT department for Starbucks, you might say, well, what laptops are available for my internal employees? And you'd want the system to be able to go and do an API call and summarize the response back to the user. And so the idea is to enable all of these things with version-controlled YAML, because that's how we do DevOps. So let's do this. Let's allow business people to create these applications, and let's version control them. Yeah, so let's go back to the slides for the last little bit. And while we do that, there's also an API calling example here. So you can see you pass in the Open API spec for one of these things. So Yeah, let's go back to the slides, please. So the way this works is that, thank you. So what we did was we got a GPU node running Linux, NVIDIA GPU. We installed Ollama on it. There's things like VLLM as well that you can use to do inference locally. We downloaded a model from Meta. We wrote some Llama index code that glued everything together. And all the code for the demo is available on my GitHub there. So feel free to check it out. And I feel like this is a good learning resource for how you can put these things together yourself. I want to just say a couple of words about productionizing what we just built. So if you just take Ollama and pgvector and you build this system yourself, then you're going to need to make it run on Kubernetes, which means you need to containerize the Python programs that we wrote. And then you will also want to scale it. So you'll want to make it work across multiple nodes so that you can have HA. And so you'll need to do something like setting up multi-node Ollama. You'll need to figure out how to integrate with APIs. And you can do that. There are patterns online, and I'm happy to talk to people about how we got that working for our use cases. And you might also then want to build an app editor on top of that to allow people in the business to enable that. You might also then want to back that with this YAML format that we're proposing, that we're in discussion with the CNCF and the Linux Foundation about adopting AI spec generally in the industry. And if you do that, then you can achieve this nirvana that I was talking about, which is GitOps for LLMs and evals. The key idea there, and I'm going to repeat it again because I think it's worth repeating, the idea is that you should be able to take version control all the things. Version control the exact version of the prompts you're using. Version control the exact version of the model, the exact version of any data that went into the RAG database, and capture that in an artifact, the same kind of artifact that you already use with tools like Kubernetes. And then run tests on that system before you deploy it to production. And how do we do that for LLMs? We use evals. And so what you do is you set up systems that can evaluate the application to check if it's good, and then run a set of tests against it. And then over time, as you're changing your application, automatically reevaluate as you're pulling in a pull request. Like you wouldn't merge a pull request without the tests passing. And so you shouldn't change your LLM application without checking that it's still working. So yeah, that's everything I've got. If you're interested in what I've talked about today, please connect with me on LinkedIn. That's my LinkedIn QR code there. And in particular, what we're doing in collaboration with JFrog is we've set up an exclusive Slack channel on the MLOps community Slack. So if you connect with me on LinkedIn, I will send you an invite. Yeah, I would love to continue the conversation online in the SwampUp Slack channel that we're setting up. And also after the talk and in the breaks, we will be wearing these very visible T-shirts in the Cloud Meetup Lounge. So yeah, come and talk to us. Thank you very much.